Good morning, students. Welcome to the lecture series of Formal Language and Automata Theory. In today's lecture, I am going to discuss the Chomsky classification of grammar. Before proceeding with the Chomsky classification of grammar, let's first understand what do you mean by a grammar. A grammar is defined by a four tuple, that is NTSP. N is your a finite set of non-terminal. Sometimes it is also represented with V. A T represents the finite set of terminal. S is the starting symbol and P is the production rule. We can represent the grammar in this way, where S, A, B are the non-terminal, small a, b are the terminal, S is the starting symbol, and the production rule is given in this way. Now, move to the Chomsky classification of grammar. Noam Chomsky was a scientist, and according to him, he classified the grammar into four types, that is type 0, type 1, type 2 and type 3 grammar. Type 3 grammar is also known as a regular grammar. Type 2 grammar is known as context-free grammar. Type 1 is known as context-sensitive grammar. And type 0 is recursively enumerable grammar. Now we will discuss each grammar in detail. What is the way of representing this type of grammar and which type of machine accepts the language generated by this type of grammar. Now, this is the tabular representation of the different types of grammar. Here we have different types of grammar, then the grammar generated by this representation, what type of language generated by the each grammar, and which type and which type of automaton accepts the language generated by a particular grammar. Now let's start with the type 0. Type 0 produces, it is also known as an unrestricted grammar, and the language generated by this type of grammar is known as recursively enumerable language. Turing machine is an automaton which accepts a recursively enumerable language. We will study Turing machine in detail in further classes. Now next we have a type 1 grammar, which is also known as a context sensitive grammar. The language generated by a context sensitive grammar is known as context sensitive language, and a linear bounded automaton accepts a context sensitive language. We have a type 2 grammar, which is also known as a context free grammar. The language generated by this type of grammar is known as context-free languages, and a push-down automaton accepts a context-free languages. And finally, we have a type 3 grammar, which is also known as a regular grammar. And the language generated by the regular grammar is the regular language, and a finite state automaton accepts a regular language. In the previous classes, I have discussed about the finite state automaton. What is a finite state automaton? How the strings are accepted by the finite state automaton. Also, what are the different types of finite state automaton and the minimization of finite automata. Now, this is the graphical representation of the different types of grammar. This represents the regular grammar. The regular grammar is a very restricted grammar. It has a very it has its own way of representation, and the regular grammar produces a regular language. Now the next circle represents the context free grammar, and the context free grammar also contained a regular grammar. Regular grammar contains only its own representation, but a context-free grammar contains both a regular grammar, it can contain regular grammar, or it may have its own representation, that is your context free grammar. And the language generated by the context free grammar is your context free languages. Now next we have a context sensitive grammar. Thus a context sensitive grammar contains a regular grammar, a context free grammar, and a context sensitive grammar. The language generated by the context sensitive grammar is context sensitive language. And the lastly we have a recursively enumerable grammar, which is unrestricted grammar because it contains regular grammar, context free grammar, context sensitive grammar, and also it has its own representation also. Now let's discuss the each grammar in detail, how we can represent a production in the case of a each grammar. We will start with the type 3 grammar. A type 3 grammar is also known as a regular grammar, and the language generated by this type of grammar is known as a regular language. Here in type 3 grammar, there must be a single non-terminal at the left hand side of the production and a while a right hand side consists of a terminal, a single terminal followed by a single non-terminal. Let's see one example. The production of the form x produces a or x produces ay. Here on the left hand side we can see that there is only a single non-terminal, but on the right hand side it consists of a single terminal or a terminal followed by a non-terminal. Then this type of production is called a type 3 grammar or a regular grammar. This grammar is very restricted grammar. Here the rule S produces epsilon is also allowed, and if S produces epsilon is a production present, then we cannot represent S on the right hand side of any rule. That we have to keep in mind, that if there is any production where a non-terminal produces a epsilon, then that particular non-terminal should not present on the right hand side of the production. Now let's see few examples of the type 3 grammar. X produces epsilon, X produces A or AY, Y produces B. This all representation represents the type 3 grammar or a regular grammar. Here X, Y are the non-terminal while A, B are the terminal, and epsilon is a empty string. Now the next three grammar will be discussed in the second session of the today's lecture.